Welcome back and hello to my favorite people. And in this lecture, I'm going to go through catalytic hydrogenation. That means we have a double bond and we want to saturate that double bond through addition of hydrogen molecule to it. So the hydrogen molecule, technically, it will get to break to atomic hydrogens, and those atomic hydrogen will be added to both sides of the carbon bond. And in order to do it, we need to have heat, and also we need to have a catalyst, a surface of a metal, a piece of metal that is going to speed the chemical reaction. But at the end, your alkene will turn to alkane, and that means we will have a carbon-carbon single bond between carbon-carbon bonds, and all carbons will be sp3 hybridization. Okay, per each double bond, you need to have 1 mole of hydrogen gas. So per technically each degree of unsaturation, in this case, we have only 1 double bond, so degree of unsaturation is going to be 1. We need to have 1 mole of hydrogen gas to do. And the reaction is going to go through a scene addition. That means it will happen from one side of the molecule. Because it's happening from one side, we say it's a stereospecific. So in the stereospecific reaction is preferring to go either from the top or the bottom. It's not going to happen, one from up and one from down or from bottom of the molecule. So either from up or bottom of the molecule, and that's the reason we call it stereospecific. Okay, next, and we have a double bond, and if we look at the double bond, this double bond is surrounded by different groups, so there is a chance to get the stereocenters. Let's give it a try. And if the addition happen, let's say the addition happened, and from the top, we might get such a molecule. So let's say addition happened from the top, these two groups, the methyl, and then here I'm going to say this one, it will be the ethyl. Okay, and hydrogen, said both hydrogen, they will be added to the top of the molecule. So we will have hydrogen there and another hydrogen here. Okay, and those are hydrogens pointing to us. And here we have CH3 and ethyl. Okay, addition happened from the top and from same side, and that's the reason we call it scene. Or we might get this one. Okay, and both hydrogens were added to the bottom of the molecule. So I'm going to show them by dash, and the methyl, it will show up, and so the methyl, it will be pointing to us. Okay, forgive me. This is going to be methyl, and this one, it will be the ethyl, and of course the ethyl, we have a carbon there. Okay, or you can say, let's go like let's keep it that way. Okay, so that's going to be the ethyl. This one is the ethyl, and this is the CH3. Okay. And as you see, we changed position of 2 of the substituent, and the CH3 and like the ethyl, they used to be down and now they are up. So these two are going to be an enantiomer of each other. And if you want to prove it, and this is going to be the configuration. Here we have 1. This is going to be, okay, let's see. Okay, and forgive me, this is going to be technically, this is going to be 1. Okay, then we have 2 here. Okay, because this one is attached to, let's see. Okay, so I go 1, and here, okay, we have CH2. This carbon is attached to carbon, and this is going to be 2 technically, and that one it will be 3. So this one it will be S configuration. And how about here? We get 1, 2, 3. This one it will be R configuration. Okay, let's give it a try here, and this is going to be 1. Okay, if I look, okay, 1, 2, 3, supposed to be R. I got S configuration, and how about this? I go 1, 2, 3, supposed to be S. I got R configuration and flipped it. So we have R and S for the top, and the bottom one, we got S and R. So these two are enantiomers. Now, why the addition is happening from one side of the molecule? The reason for it, we're going to use the surface of catalyst, and that surface of catalyst and under heat and also interaction with the double bond, it will lose the double bond, it will make it weaker, and also it will break the hydrogen bond. Okay, so we will have atomic hydrogen attached to the surface. And if you look at the double bond, when the double bond gets interaction with the surface, here the double bond got interaction with the surface. Very soon, one hydrogen here, let's say, for example, this hydrogen, I'm going to pick one of them, this hydrogen will be given to the double bond, and now we have hydrogen attached to carbon, and this carbon is saturated now. Okay, now this carbon still is not saturated. Why? Because it's attached to the surface, and maybe I should not say it's not saturated. It is saturated until it's attached to the surface. But if hydrogen get involved, hydrogen will be given to that carbon, and if that hydrogen get attached, now no need to have any interaction with the surface. Very soon this carbon will leave the surface because that carbon now is saturated, and both carbon are saturated, and then they can leave the surface and keep it empty. So next molecule, next alkene will get interaction with the surface and try to grab some of those atomic hydrogen that attach to the metallic surface. Okay. Again, the addition is seen, and we say we have stereospecific. That means addition is going to happen only in one side of the molecule. Okay, and last example. Okay, we can have addition. Okay, either to the top or bottom of the molecule. So let's say addition happen to the top of the molecule, and then we get H here, H, and that means the methyls, they will be back of the molecule. So methyls are back here. And another one, I go methyl, it will be there. Okay, or okay, I might get this structure. Methyls are facing to us, and the hydrogens are back of the molecule. So let's put hydrogens here. Okay, maybe I should also put the methyls same position. So just to be okay, let me erase that part. Put the methyl same position. Okay, so I got CH3 here, CH3 there. This molecule clearly it has plane symmetry. So this molecule, even it has stereocenters. Those are the stereocenters. It has two of them, but it will be meso because it has a mirror. Okay, and if I redraw this molecule, okay, this molecule, we said addition of the hydrogens will happen from the top. Okay, so hydrogen, we're going to add them here. Those are hydrogens. And the methyls will be back of the molecule. So we get CH3 there. And here as well, CH3. And those two are hydrogens. Okay, again, we do have stereocenters, but we have a mirror. And that mirror is going to make the system optically inactive. Okay, and so we say meso. Why meso? Because we have a stereocenter, but it's not active. And I'm going to stop the lecture here, and thank you very much.